Hi everyone, Mrs. Besega here, and this is this week's Week in Review. This week's big idea was velocity versus time graphs. We use them to define acceleration as the change in velocity per unit time. That means acceleration is actually the slope of a velocity versus time graph. We talked about how we could get the change in position by taking the area under a curve of a velocity versus time graph, which makes it a very powerful tool. Finally, we looked at the special velocity versus time graphs for freefall. So, acceleration, that's the change in velocity per unit time. And that means if I knew an initial velocity of a situation, like let's say I know the initial velocity is 10, right? And I know the acceleration is 3 meters per second squared, that means every subsequent second would be 3 meters per second faster than the one before it. So starting at 10, counting up by threes, every second gets 3 meters per second faster, yielding a graph that starts with a y-intercept of 10 and a positive slope of 3. So we could use slope to calculate the acceleration from a graph. In this case, we'd take any 2 points along that line and calculate slope. Now let's talk about what this graph means. If I have a forward velocity, that means my graph is above the x-axis. But any negative velocity, no matter what shape it's making, as long as it's below the x-axis, that means you're going backward. Finally, any point that's on the x-axis means your object is stationary. The accelerations can be read off this graph, sure, by calculating slope, but I can see very quickly where it's positive, negative, or zero acceleration. So now let's deal with a calculating example. To calculate acceleration, I would take the slope of any 2 points along the line. I don't really have to do that from 4 to 12 seconds because I can see off the top of my head that that slope is 0 already. I'm taking the initial and final velocities and dividing it by the change in time over that time increment. In this case, it gets 6 meters per second more negative in 8 seconds, yielding an acceleration of negative 0.75 meters per second squared. Now let's deal with that other tool, area under the curve. And I'm going to break this up into 4 shapes: a triangle, rectangle, triangle on the top, and a blue below the curve triangle on the bottom. For triangles, I'm going to calculate an area using 1/2 base height. In this case, a height of 4 and a base of 8 gives 16 for an area. The rectangle in the center is an 8 by 8, so a 64 meter forward. Finally, up on top, I've got another triangle, so that's 1/2 10 times 8, or 40 meters forward. An important thing to note for the blue triangle is because it's below the axis, this is actually going to give me a negative change in position. Now, what I can picture when I'm looking at this is I see that it moves forward 16, then 64, then 40 meters, and backward 48. I'm actually picturing a number line in my head. So let me draw this out what I'm thinking about. So, walking forward 16 from the origin, then 64, then 40, backward 48. And so where I end up is my change in position. I'm ending up 72 meters ahead of where I started. So I did 16 plus 64 plus 40 minus 48 to get a change in position of 72 meters forward. Finally, free fall. For these, we were doing a very special velocity versus time graph. So to figure out how to draw the graph, I need to be given some starting information. And let's say the starting information is I'm gonna chuck as fast as I can a ball up to my friend who's on the top of this building here. And I see that it takes 6 seconds to reach the apex and 2 seconds to fall back into their hands. Okay. The number that I know and I'm given in that wording is I know that the velocity at 6 seconds is 0 because that's the apex. With an acceleration of 9.8, that means any earlier second of time was 9.8 meters per second faster in the positive direction, and any later increment of time after the apex had a more negative velocity. This lets me find both by initial and final velocity. But how do we find the height of the building? Okay, easy peasy. I'm going to make a graph of velocity versus time. And in my graph of velocity versus time, I'm going to have the apex at 6 seconds. I'm going to have it start at 0 and at 8. And I've already calculated the initial and final velocities on the earlier slide. Okay, so I'm going to start at 58 something meters per second and at about negative 19.6 meters per second. Draw a straight line all the way through, and it's close enough, guys. I'm trying. If I want to find the height of a building, I know I'm taking area under the curve. So area of the pink triangle is 1/2 6 times 58.8. Area of the blue triangle is 1/2 2 times 9.6, or 19.6. So all in all, we see that it moved 176.4 meters upwards, stopped at 6 seconds, and then moved 19.6 meters per second downward. Seeing this side by side with the building, we see that if it travels 176.4 meters upward, then falls 19.6 meters downward, the final height of the building can be found by subtraction. To sum it all up, this week we looked at the definition of acceleration, how to calculate it from a velocity versus time graph, how to use the area under a curve to find the change in position, and finally, the special velocity versus time graph for free fall. That's all, folks.